So let's go ahead and walk through this problem where we're going to do not only a hypothesis test, but we're also going to relate it to its corresponding confidence interval. Let's go ahead and read this question. So the question starts here. Among 2,063 passenger cars in a particular region, 221 had only rear license plates. Among 380 commercial trucks, 54 had only rear license plates. A reasonable hypothesis is that the commercial truck owners violate laws requiring front license plates at a higher rate than owners of passenger cars. Use a 0.01 significance level to test that hypothesis. So first, we're going to identify the claim. So based on the information we were given these two proportions, right? 221 out of 2,063, and then 54 out of 380. And this was giving us the proportion of either passenger cars or commercial trucks that had only rear license plates. So these are the people that are not obeying the law that's requiring the front license plate. And the claim is that the commercial truck owners are violating the laws at a higher rate than the owners of the passenger cars. So that means that this proportion for the commercial truck drivers should be higher than the proportion for the passenger cars. So now down here it says let population 1 be the passenger cars and population 2 be the commercial trucks. So if the commercial trucks have a higher rate, that means their proportion is higher. So population 2 proportion would be higher, greater than the population 1 proportion. So if we look through our options here, we're looking for the option where P2, the proportion from population 2, is larger, greater than the proportion from population 1. So that's going to be this one down here. See, P2 is greater than P1. So we're going to select that one. So moving on, now we're going to identify the test statistic. For this, we're going to use technology. Specifically, we're going to use Statcrunch. So I'm going to go up here to Question Help, and I'm going to choose Statcrunch to open the program. Now I'm going to see what I can do about making this as small as possible so we can use it but also see the problem. Hopefully everyone can see this. So to do a hypothesis test about two proportions, right, we're comparing two proportions, I'm going to go to the Stat button, I'm going to go to Proportion Stats, and I'm going to go to To Sample. Okay, so I want to do proportion stats because this is a hypothesis test about proportion, and I'm comparing two different proportions, so To Sample, and I'm going to choose With Summary because what they gave us was the two proportions from the two samples from the passenger car and the construction trucks. So With Summary. So for sample 1, that was the passenger cars, there were 221 out of 2,063 that had only rear license plates. So the number of successes, meaning the ones who only had rear license plates, was 221, and the number of observations, the total number, is 2,063. Now for the second sample, that was the commercial trucks, there were 54 that had rear license plates only out of a total of 380. So this is going to be 54 out of 380. Now if we go down, we need to set our alternative hypothesis. Again, this was the hypothesis that was correct. This is the one that's corresponding to our claim. So I want P1 to be less than P2. Another way to say that is if I subtract P2 from P1, I should get something that is less than 0. Just remember back to your algebra, if you had something like this, and you subtracted P2 from both sides of the inequality, you would get P1 minus P2 on the left and 0 on the right. So this statement right here is the exact same relationship as this statement right here. So we're going to go ahead and go down and click Compute. So just like that, Statcrunch gave us the test statistic, which is here under Z-stat, and it also gave us the p-value and a bunch of other information. So the test statistic here asks us to round to 2 decimal places, so it's going to be a negative 1.98. negative 1.98. That's correct. So now it's asked us to find the p-value. Back to my Statcrunch results, I see the p-value right here is 0.0237, and this is asking us to round to 3 decimal places, so that would be 0.024. 0.024. 0.024. So that's correct. So now we are asked to state a conclusion about the null hypothesis as well as a conclusion about the original claim. So what I notice here is my p-value is 0.024. That value is larger than my significance level, which was 0.01. When the p-value is larger than the significance level, that means you are going to fail to reject the null hypothesis. So let's say that again. When the p-value is greater than the significance level, you will fail to reject the null hypothesis H0. So that means it has to be automatically either B or D, because those are the only ones that say fail to reject H0. So now the question is, did we support our claim or not? Let's go back up to the first part. So my null hypothesis said that P1 was equal to P2. That means the proportion of people who had only rear license plates was exactly the same for the passenger cars and the commercial trucks. No difference. My alternative hypothesis said that the commercial trucks actually had a higher rate of having only rear license plates. The commercial trucks population 2 was more than population 1. When I decided to fail to reject my null hypothesis, I said, okay, well, this was my null hypothesis, that the two proportions are equal, and I did not reject that. If I do not reject it, that means that I think that it might be the case. I don't have enough evidence or strong enough evidence to reject it. So that means that while I haven't necessarily supported my null hypothesis, I have not found cause to reject it. So if I have not rejected this statement, in other words, I've basically accepted it as possible, that means I have not supported this statement. I have two separate statements here. I must support one and not support the other. If I fail to reject the null hypothesis, that means that I'm in effect supporting it, so I am not supporting the alternative hypothesis here. In this case, this alternative hypothesis was my claim, right? The claim was that the second proportion was going to be more than the first proportion. So I have not supported my claim. So going back down, I would say there is not sufficient evidence to support the claim that commercial truck owners violate laws requiring front license plates at the same rate, at a higher rate, as the owners of passenger cars. Now finally, we're going to identify a confidence interval here that's going to correspond to the same hypothesis that we set up. Now to do this, let's take a look at the graph. This was my null and alternative hypothesis right here. The null hypothesis was that H0 was P1 equal to P2, and the alternative hypothesis, H1, was that P1 is less than P2. So remember back to that nice picture that we've been using all along of that bell-shaped curve. So in this case, based on the direction here of my alternative hypothesis, this is going to be a left-tailed test. You can think of the direction of the inequality sign as being like an arrow, right? Kind of looks like this. So it's pointing to the left, right? So that means this is a left-tailed test. So somewhere over here on the left, I have a place where I mark my graph, and then if I shade into this tail here, this is the area that I'm talking about for my rejection region. Remember, we had that the significance level was 0.01. So that means that here, this area here in the left tail is 0.01. Okay? Now, this hypothesis test was a one-tailed test, but a confidence interval is always two-tailed. So right now this picture is not giving me what I need for a confidence interval because I only have this one tail. So what we're going to do in order to generate an appropriate confidence interval to correspond to this particular hypothesis test is we have to convert this one-tailed test into a two-tailed confidence interval. So since I had a value of 0.01 over here on the left, again the 0.01 came from the significance level that I was given, I'm going to just mirror that and give myself another tail over here on the right, also of 0.01. So now this looks like what I need for a confidence interval. I have a tail on the left and a tail on the right. Now, if I have these two tails and they're both 0.01, that means that together the two tails, if we added them together, would be a value of 0.02, right? So what's left over in the middle here? Well, if I have 0.02 outstretched between the two tails, and the area under the entire curve is 1 or 100%, that means that left here in the middle is going to be 0.98, right? 0.01 plus 0.98 plus 0.01 is going to equal 1, which is equivalent to 100%, right? You can think of this as you want, if you want as 1% and 98% and another 1%. Same idea. So the confidence level that I need in order to produce a confidence interval that will correspond to this particular hypothesis test will be 98%. Now if I come back to Statcrunch, I can go ahead and generate that 98% confidence interval with this information. So to do that, I'm going to go back to the stat key. I'm going to go to proportion stats, and again I'm going to go to toSample with summary. And I'm going to enter this information again. So this was 221 out of 2063 and 54 out of 380. Remember, this is the same information that we had before, just re-entering it again. And now, instead of doing a hypothesis test, which we were doing before, I'm going to select to do a confidence interval. It defaults to doing a hypothesis test, so we do need to select this specifically. And for the confidence level here, again, I said it was 98%, so we enter it here as a decimal as 0.98, and I'm going to click compute. So this is my confidence interval. This is the lower limit, and this is the upper limit. So here I was asked around to 4 decimal places, so I'm going to have 0.0796 and 0.0096 again. So there we've got those entered. Check. So that is the correct confidence interval. Now, because the confidence interval limit do contain 0, right? This is a negative number and this is a positive number, so 0 has to be in the middle of a negative number and a positive number. There is not a significant difference between the two proportions, right? Here in the middle, I have the difference between the two proportions. Well, if I can subtract one proportion from another and I get the value 0, that means that the two numbers had to be the same. The only way I can get 0 after subtracting two numbers is if they were the same. And if they are the same, that of course means that they are not different. So, there is not sufficient evidence to support the claim that the commercial truck owners violate laws requiring front license plates at a higher rate than owners of passenger cars. I, in fact, have evidence that they might be the same.